Imagine stepping into a room, right, where a fierce, just highly intellectual debate is happening.
Oh, yeah, you can practically feel the tension.
Exactly. I mean, the energy is palpable. People are leaning across the table, voices are raised, hands are slamming down for emphasis.
A real passionate argument.
Right. They're arguing passionately about the future of humanity, the fate of our species, the whole deal. So you sit down in the back, totally captivated.
Like anyone would be, honestly.
You listen for a solid 30 minutes, nodding along, trying to pick a side. But then, slowly, this bizarre realization creeps in.
Let me guess. They aren't even talking about the same thing.
Exactly. These two sides are arguing about completely different things. They aren't even having the same conversation.
It's that classic scenario where, everyone in the room is using the exact same vocabulary, but the dictionaries they're secretly pulling those words from are completely different.
Yeah, and honestly, nowhere is this more prevalent or more dangerous today than when we talk about AGI, artificial general intelligence.
Oh, absolutely. It's a massive issue right now.
That is the core of our deep dive today. We are looking at the absolute necessity of defining our terms in public debates, specifically focusing on this huge, almost invisible rift in how AGI is defined.
Because right now, arguing about the future of AI without a shared definition is just, well, it's leading to polarized, unproductive chaos.
It really is. It feels exactly like two people aggressively arguing over who the best athlete in the world is, right?
Oh, that's a good analogy.
Like, one person is arguing passionately for a chess grandmaster, focusing entirely on strategy, mental endurance, pattern recognition.
Right, which takes immense skill.
But the other person is shouting about an Olympic weightlifter. They're focusing on raw physical power and kinetic output.
Yeah, and they are both using the word athlete. But if you don't define the game you're playing, the debate is entirely meaningless.
That analogy hits the nail on the head, I think. Early on in computer science, researchers just threw around the term AI. It was this overarching, almost mythical goal.
Right, but as the technology actually advanced, we kind of kept moving the goalposts.
We did, yeah.
We realized that a machine beating a human at chess or, summarizing a legal document wasn't that magic threshold of intelligence we thought it was.
So the term AGI was born to represent the real deal, human level or beyond.
But now, that very term has splintered into completely different schools of thought.
And to explore how deep this splintering goes, we're pulling from a really interesting stack of materials today for you.
Some really great sources, yeah.
We've got essays from independent researcher and writer Jorge Guerra. He's been specifically exploring his work on computational thinking.
Which is all about how computers think, decide, and learn, and how that applies to human decision processes.
Exactly. We're also looking at a transcribed debate on AI and morality featuring Pyers and the historian Dr. Richard Carrier.
A really intense debate, by the way.
Oh, very. And to anchor the underlying mechanics of all this, we're diving into foundational concepts from Judea Pearl's incredible book, The Book of Why.
The contrast in these sources is perfect for our mission today, because they really represent the two main camps fighting for the definition of AGI.
And if you're listening to this trying to figure out if AI is going to take your job or, solve climate change, you need to know which camp the person talking to you belongs to.
You absolutely do.
Let's start with the first major camp. We can call this the functional perspective. This is where Jorge Guerra really plants his flag.
And for some context, Pierce has a fascinating background.
Yeah, tell us a bit about that.
Well, he has a Ph.D. in bioinformatics. He spent years in academic research across institutions like the University of L'Aquila, USP, and Fiocruz.
Oh, wow.
Right before shifting into writing and making science accessible. So he comes at this with a very intentional, engineering-heavy, biological modeling mindset.
Okay, so a very structural approach.
Exactly. For him, an AGI is defined by its utility. It's a system capable of performing a wide variety of intellectual tasks, transferring knowledge across different domains, and adapting to unfamiliar problems.
And it does all that without needing a totally new architecture built from scratch for every single task.
Right. It's all about capability. What can the machine actually execute?
Like, can it switch between writing an essay, solving a calculus problem, and then writing Python code?
Yeah, much in the same way a human worker might switch contexts during a workday. But what makes Pyers' definition, and the functional camp's definition in general, so important is what it explicitly leaves out.
Right, hold on, because this is where the debate usually derails. Notice what the functional definition does not require.
It doesn't require a soul.
Exactly. Pyers points out that an AGI doesn't necessarily need phenomenal consciousness.
And we should probably define that, because phenomenal consciousness is a pretty dense philosophical term.
Yes, please. Break that down for someone who hasn't spent 4 years in a philosophy seminar.
Think of phenomenal consciousness as the feeling of an experience. It's the subjective inner movie playing in your head.
Like when you eat something delicious.
Exactly. When you look at a red apple, your eyes process the light waves. That's the mechanical part.
Mm.
But phenomenal consciousness is the actual feeling of seeing red.
The subjective experience of the color, the crispness of the bite, the memory it evokes.
Right, the functional camp says, look, an AGI does not need that inner movie. It doesn't need subjective experience, free will, emotions, or self-awareness.
It doesn't need to feel the color red to paint a red apple.
Boom, exactly.
Which feels a bit counterintuitive to how we normally think about intelligence, right? We kind of assume that to be as smart as us, a machine has to feel like us.
We do. It's human nature to project that.
But Pyers is arguing that the internal experience is totally irrelevant to the output. And what really surprised me in the research is that this functional, almost cold view of intelligence is basically the reigning consensus across the biggest tech companies in the world right now.
Oh, it absolutely is. If you look at OpenAI's charter, they define AGI as highly autonomous systems that outperform humans at most economically valuable work.
Notice the phrasing there, economically valuable work.
Yeah, there is zero mention of consciousness or self-awareness.
None. And DeepMind evaluates AGI based on breadth of capabilities, level of performance, and autonomy.
Even Gary Marcus, who is often a massive critic of current AI, still describes AGI as a flexible, reliable, and resourceful intelligence.
So the entire industry is aligned around the idea that AGI is defined by what it produces, not how it feels while producing it.
And Pyers uses a really compelling biological and historical precedent to back this up, drawing from his background in bioinformatics.
Right, because we tend to view our own human intelligence as this monolithic, magical, glowing orb in our heads.
But from a biological standpoint, the brain is highly modular, isn't it?
It's highly modular. You have different neural systems specializing in entirely different tasks.
One area processes visual stimuli, another handles language generation.
Another deals with spatial memory, another with motor control. They are specialized tools continuously interacting.
And Pyers points out that science itself is modular. If you want to understand reality, you don't use one giant universal formula.
Right. Physicists use quantum simulators. Epidemiologists use compartmental models. Economists use market graphs.
So the functional argument asks, why on earth should we demand that an artificial intelligence be one giant, homogeneous, conscious, computational unit?
When neither nature nor human science works that way, that makes a lot of sense.
I love the historical analogy he makes here about engineering versus biology.
Oh, the flying one.
Yeah. We always try to copy nature at first, and then we realize engineering requires a different path.
Like when we wanted to fly, early inventors literally built machines with flapping wings because they were copying birds.
The ornithopters, right, and they were terrible.
Exactly, they were awful. It wasn't until we stopped trying to mimic the biological mechanism of flapping and instead focused on the functional physics of lift and thrust that we got airplanes.
An airplane doesn't look or act like a bird, but it achieves the function of flight.
Right, and digital cameras don't have biological retinas or optic nerves, but they capture images perfectly well.
So why are we demanding that an artificial intelligence perfectly mimic the biological mechanism of human consciousness?
The functional camp's conclusion is that if a system can successfully coordinate specialized tools to solve a massive range of general problems, it has achieved AGI. Full stop.
Whether it feels the joy of solving the problem is a question for theologians, not engineers.
Okay, I have to jump in here and play devil's advocate for a second. Because if an AGI is really just a bunch of specialized tools coordinated together to give an output, isn't that just a really fancy digital Swiss Army knife?
I mean, that's a common critique, yeah.
If I have a tool that has a screwdriver, a knife, and a corkscrew, it's incredibly useful. But I don't look at the Swiss Army knife and call it intelligent.
Right, you call the person using it intelligent.
Exactly.
Yeah.
So how does the functional camp bridge the gap between a collection of tools and actual intelligence?
That is the exact friction point, and it's a great question. Pyers addresses this by looking at how modern large language models, or LLMs, are currently evolving. He focuses on a concept called function calling. To understand why this elevates a system from a dumb tool to an intelligent agent, we really have to look under the hood.
Right. Let's unpack function calling. How does it work?
Well, When you ask a basic language model a complex math problem, say multiplying two massive numbers, its instinct is to treat it like a language problem.
Because it's a language model.
Right. It tries to predict the next most likely token, or word, based on patterns it saw in its training data. It's essentially guessing the math based on vibes.
And it often gets it terribly wrong.
Oh, absolutely. But with function calling, the architecture is different. The model is actually trained to recognize its own limitations.
Wait, it knows what it can't do.
Exactly. It reads the prompt, realizes, oh, I am a language model, I cannot do raw computation.
Wow.
And instead of guessing, it writes a small piece of code, sends that math problem to an external Python calculator, waits for the calculator to solve it, and then reads the result back to you in plain English.
So it's like a waiter at a restaurant. You ask the waiter for the chef's special. The waiter doesn't go to the table and start trying to cook the meal in front of you.
That would be a disaster.
The waiter takes your request, goes to the kitchen, which is a specialized tool, gets the food, and brings it back to you.
That is a beautiful analogy. The waiter is the orchestrator. If you ask an LLM for the weather in Tokyo, it doesn't try to hallucinate the barometric pressure.
Because it can't feel the weather in Tokyo.
Right, so it pauses, writes a query to a live weather API, an application programming interface, which is just a bridge to an external database, pulls the live data, and formats it for you.
So Pyers is saying that the intelligence isn't necessarily having all the answers inside one massive brain.
Right.
The intelligence is knowing which expert to consult, how to ask the question, and how to deliver the answer.
Yes, exactly. Knowing which tool applies, translating the user's messy natural language into the strict code the tool requires, interpreting the raw data the tool spits back, and integrating that into a broader explanation.
That orchestration is a profound form of cognitive work.
Pyers argues this is computationally intelligent. You don't need to be a calculator to be a mathematician. You just need to know how to use the calculator to prove the theorem.
I can completely see why Silicon Valley loves that definition. It's measurable. You can build it, you can test it, you can sell it.
Very pragmatic.
But, and this is a big but, it feels like something is missing. It feels a bit hollow.
I get that.
And that brings us to the flip side of the coin. While the functional camp is hyper-focused on what the machine can do, there is a completely different, deeply rooted philosophical and cognitive tradition that is looking entirely at how the machine thinks.
And they're looking at the current trajectory of AI and saying, you guys are building a massive house of cards.
A house of cards. That's a strong claim.
It is. This perspective is heavily represented in our sources by Dr. Richard Carrier from The Debate and the legendary computer scientist Judea Pearl.
Judea Pearl's work in the Book of Why is essentially the counter-manifesto to the functional camp.
Yeah, it really is.
Pearl makes a claim that is honestly startling when you first read it. He argues that pure data, no matter how massive the data set, no matter how many petabytes of internet text you scrape, is, in his words, profoundly dumb.
A very provocative phrase, especially today when data is treated like the new oil.
Right. But Pearl backs it up with rigorous mathematics. His core argument is that deep learning and modern LLMs are fundamentally architecturally limited because they rely entirely on statistical associations and pattern matching.
They are incredible at mapping correlations in a high-dimensional vector space.
Okay, pause. High-dimensional vector space. Let's translate that for someone who might be walking their dog right now and isn't a machine learning engineer.
Fair enough, fair enough.
How exactly is an LLM mapping these correlations?
Imagine a massive three-dimensional room. Every word in the English language is a little glowing orb floating in this room.
Okay, I can picture that.
The AI's job during training is to group words that are related close together and push words that are unrelated far apart.
So, like, the orb for king and the orb for queen are floating right next to each other.
Exactly. Dog and puppy are close. Dog and carburetor are on opposite sides of the room.
Makes sense.
So when you give the AI a prompt, it looks at the words you used, finds their location in this room, and mathematically calculates which word orbs are closest to the ones you just gave it.
It predicts the next word based on distance and probability.
It's a statistical proximity game.
So it's incredibly sophisticated, but at its core, it is just recognizing that word A usually appears near word B.
Right, and Pearl's critique is that while this creates the illusion of understanding, it lacks genuine causal reasoning.
Because it doesn't know what the words mean.
Exactly. The machine knows that rain and umbrella are grouped together in the room, but it has no idea that the rain causes the umbrella to open.
It doesn't understand cause and effect.
No, not at all.
To really drive this home, Pearl created something called the ladder of causation.
Yes, this is brilliant.
This is the framework he uses to prove why current AI isn't actually thinking. The ladder has 3 rungs, and it is vital for understanding this debate. Let's walk through them. What is rung 1?
So rung one is seeing, or observation. This is the realm of pure statistics and correlation.
Like just passively seeing patterns.
Yeah, exactly. This is where every single animal in the wild and every single current AI model currently lives. It's about detecting passive patterns in the environment.
Okay, give us an example.
For example, a machine learning model might be fed thousands of street camera images. It notices that whenever it sees people carrying open umbrellas, it also sees wet sidewalks.
It recognizes the correlation perfectly.
But it doesn't know why they are correlated. It just knows they show up at the same time.
Precisely. If you ask a rung 1 AI, I see an umbrella, is the sidewalk wet? It will correctly answer yes, based on probability.
But it doesn't understand the physical mechanism of water falling from the sky.
And that brings us to rung 2, doing or intervention.
This is where we step beyond just observing and start messing with the world.
Exactly. Rung 2 asks the question, what will happen if we do X? To successfully navigate rung 2, you have to understand the causal mechanism, not just the correlation.
Let's go back to the street camera. If I magically confiscate everyone's umbrella and force them to close them, will the rain stop?
A pure rung 1 observer in AI might genuinely guess yes, because in its data, umbrellas and rain always appear together.
Right. If you remove the umbrella, statistically, the rain should disappear too.
Because it doesn't understand the causal direction.
But a rung 2 thinker, like a human toddler, understands the physical mechanism. Rain causes umbrellas. Umbrellas do not cause rain.
You can intervene and take the umbrellas away, but the water will keep falling.
That is a massive leap in cognition. But Pearl goes even further. What is rung 3?
Rung 3 is imagining, or counterfactuals. This is the top of the ladder.
Holy Grail.
Yeah, it's the ability to reflect on past events and ask, what would have happened if I had acted differently?
It's the capacity to imagine alternative realities that never actually occurred, to reflect on errors, to assign blame, to feel regret.
Like, if I hadn't taken that specific route to work, would I have avoided the car crash?
Exactly. You are running a mental simulation of a universe that doesn't exist, based on your understanding of physical laws. Pearl argues this is where true human-level intelligence resides.
And Pearl is so confident in this framework that he actually proposes a new kind of test for AGI, right? A mini Turing test.
Yeah, because the original Turing test, proposed by Alan Turing back in the 50s, basically just tests if a machine can mimic human conversation well enough through a text screen to fool a human judge.
Right, and Pearl points out that in the age of LLMs, the Turing test is basically obsolete.
We know that a machine can fake a conversation using run 1 statistical probability. It's just stringing highly probable words together.
Pearl's mini Turing test throws out conversation and instead requires the machine to answer simple causal questions that a human 3-year-old could answer without thinking.
He uses this incredible example of a firing squad to illustrate how a machine fails this test.
Let me set the scene for you. Imagine a firing squad of 5 soldiers. The rules are strict. If the commander gives the order, all 5 soldiers shoot their rifles simultaneously and the prisoner dies.
Simple enough.
Now, you feed all this data to an AI, it learns the pattern perfectly. Commander orders, 5 guns fire, prisoner dies.
So far, so good. The AI has mapped the correlation.
But then you ask the AI a rung 3 counterfactual question. You ask, suppose the commander didn't give the order, but a rogue officer ran up, grabbed one of the soldiers' rifles, and physically forced him to pull the trigger. Would the prisoner die?
Now, a human child understands that, yes, a bullet entering a body from one gun still causes death, regardless of whether the commander yelled a word beforehand.
Because we understand the physical mechanism of a firearm.
Exactly. But a purely statistical run 1 AI struggles profoundly with this.
Why? Why can't it just guess?
Because in its training data, it has only ever seen the complete sequence. Commander orders, 5 shoot, death. It has absolutely no statistical precedent for a lone shooter in this specific context. Because it doesn't understand the physical mechanism, it doesn't have an internal causal model of a bullet traveling through the air and damaging tissue, it can't confidently answer the question.
It might guess based on some distant text about lone shooters, but it isn't reasoning. It's just searching its vector room for floating orbs.
This reminds me of the broken leg paradox that comes up in the debate between Pyers and Carrier.
Oh, that's a classic problem that perfectly highlights the frustration of dealing with rung one intelligence.
Let's lay it out. Say you have an AI assistant that analyzes your habits to optimize your life. It knows that every single Tuesday for the last 3 years, you go to the cinema.
It's a rock-solid statistical correlation.
But today, Tuesday morning, you fall down the stairs and break your leg.
Ouch. Well, any human friend instantly knows you aren't going to the cinema today. The human understands the causal mechanism.
We know a broken leg means a cast. A cast means you can't bend your knee. Cinema seats are cramped and narrow.
Therefore, sitting in a cinema with a cast is agonizing, so you will stay home. The human runs a rung 3 counterfactual simulation of your body in the theater seat.
But the AI assistant living on rung 1 doesn't have a body, and it doesn't understand space. It just looks the data points.
Now, maybe it's very advanced AI and it cross-references hospital data.
Sure, it notices a broad statistical trend that people with broken legs who check into the ER don't usually visit cinemas on the same day, so it might accurately cancel your movie ticket.
But, and this is the vital distinction, it doesn't understand the physical reality of a cast in a theater seat.
It just knows the data points broken leg and cinema attendance have a negative correlation. If you ask it why it canceled the ticket, it will just point to the math.
It's exactly why automated customer service systems are so infuriating. You're trying to explain a nuanced, unique situation like, my flight was delayed because a bird flew into the engine, so I missed my connection. But the system says I was a no-show.
And the bot just keeps repeating the policy.
Right, because it doesn't understand the causal chain of the bird, the engine, and the time delay. It just sees the no-show data point.
Exactly. And if we connect this to the bigger picture of the AGI debate, this is why Carrier and Pearl argue that the functional camp is dangerously misguided.
They argue that until an AI possesses a sophisticated internal model of reality, until it graduates to rung 3 and possesses true causal understanding, it cannot be considered a general intelligence.
It's just a highly advanced pattern matcher wearing a mask of intelligence.
Okay, so let's ground this. If you're listening to this on your commute or while you're doing the dishes, you might be thinking, okay, this is a fun philosophy seminar, but who cares if the AI doesn't know why the umbrella opens or why the bullet kills, as long as it gives me the right answer?
Right. Why does this difference between functional pattern matching and true causal reasoning actually matter to everyday life right now?
It matters because the general public is deeply confusing the two. People assume these machines are on rung 3 when they're really on rung 1.
And that confusion is opening the door to massive manipulation in public debates, politics, and society at large.
If you don't define the terms, you become a victim of the machine's architecture.
Yes. The danger of garbage in, garbage out is no longer just a coding error. It is an existential problem for truth.
In the transcribed debate, Richard Carrier makes a point that should give everyone pause. He says current LLMs don't even know what words mean.
Which goes back to our vector room analogy. The machine is simply looking for the statistical juxtaposition of text on the internet.
Carrier uses a really simple example. If you ask an AI to describe a Christmas tree, it will tell you it is green, has needles, and is conical.
But the AI doesn't actually possess a spatial, three-dimensional understanding of a cone.
It has never run its hand over a cone. It doesn't know what a shape is.
It just knows that the word Christmas tree and the word conical frequently appear near each other in its training data.
Which means the AI has absolutely no anchor to physical reality or to objective truth.
Its only anchor is volume. If a word appears frequently enough, it becomes true to the model.
Which means if you can control the volume of data, you can control the AI's version of reality.
The sources highlight some highly specific, real-world examples of how AI is being manipulated right now because of this exact vulnerability.
Let's look at example 1 from the debate, which focuses on manipulating the AI's logic directly. There is a story about a user, we'll call him Mike to keep it simple, who decided he wanted to force an LLM to validate his highly specific beliefs about a global flood myth.
And we should clarify here, Mike wasn't just asking the AI a question. He was engaging in deliberate prompt engineering. He was blinding the model.
Exactly. Mike literally prompted the AI to ignore all established scientific consensus.
He told it to ignore modern physics, ignore the geological record, ignore atmospheric science, and only use the specific logic and data points he was about to provide.
He created a walled garden of data.
He fed the AI dozens of isolated historical accounts and myths of floods from different ancient cultures all over the world. But he presented them to the AI with the premise that they were all independent accounts of the exact same global event, rather than localized river floods occurring thousands of years apart.
And the AI, operating strictly on probability and the confined rules Mike set, analyzed the text.
It didn't step back and use rung-3 reasoning to ask, wait, how could it rain enough to cover Mount Everest?
It just processed the statistics of the text it was allowed to see. Eventually, it output a statement telling Mike that based on having over 200 supposedly independent historical accounts, there was a 99% probability that a global flood actually happened.
And this is the dangerous part. Mike then triumphantly took a screenshot of this output and broadcast it online, claiming, look, AI has mathematically proven my point.
When in reality, the AI proved nothing about history. It only proved that if you force a mathematical formula to only look at one side of an equation, it will give you a biased result.
It's a perfect case study in data poisoning. The AI didn't understand the causal realities of the world. It just processed the statistical rules it was given.
Which brings us to an even more complex vulnerability discussed in example 2 from the debate. This example deals with how an AI evaluates abstract human concepts like theology and religion.
The debate hosts discussed a case where an AI model was prompted to objectively evaluate different faiths based on its entire training data.
And before we get into the result, we need to explicitly state to you, the listener, that we are not taking a stance on these religious examples or the flood myth.
Right, absolutely not. We are strictly highlighting these stories from the source material to demonstrate how volume-based data models can be manipulated to validate any user's pre-existing bias.
Right. So looking purely from a data mechanics perspective, the result was striking. The AI output a claim that Jehovah's Witnesses were a terrible religion, but that Catholicism was the best religion.
Now, if you think the AI is on rung 3, you might read that and think, wow, the supercomputer analyzed the complex moral theology, the historical impacts, and the ethical frameworks, and made a definitive moral judgment.
But did it do that? Absolutely not.
No, it was entirely based on the sheer volume of text available on the internet. It was just a numbers game.
Think about the data the AI is scraping. For Jehovah's Witnesses, there is a massive amount of modern negative press, critique forums, and ex-member testimonies highly concentrated online.
The ratio of negative text to positive text is heavily skewed, which dragged its statistical sentiment score down.
Conversely, Catholicism has a vast, globally funded, centuries-old infrastructure producing positive literature, history, art descriptions, and media.
You have Thomas Aquinas, Augustine, thousands of books digitized.
The volume of culturally embedded positive text simply outweighs the modern critique in a raw statistical scrape.
The AI was just reflecting the weight of the library.
It's not making a moral judgment, it's just weighing the books. But if you don't understand that, if you think the AI is an AGI with causal reasoning, you look at that output and think the machine has discovered a profound moral truth.
And that is terrifying. Because bad actors, whether they are political action committees, massive corporations, or state-sponsored bot farms, know exactly how this architecture works.
They know that if you can flood the internet with enough specific word juxtapositions, the AI will eventually absorb that as truth and regurgitate it to the public as an objective, machine-verified fact.
This leads us to a massive pivot point in our deep dive. Because if current AI is this easily manipulated, this easily captured by sheer volume and bad data, what happens when we try to use it for high-stakes governance?
What happens when we put it in charge of policy or law or warfare?
This brings us to a really fascinating thought experiment that Pyers and Carrier spent a lot of time debating. They call it the concept of the institutional AI Moses.
The AI Moses. It sounds like a sci-fi novel, but the premise is grounded in very real political frustration.
The argument starts with a basic truth. Human politicians are deeply flawed.
They are easily lobbied by special interests, they have immense personal biases, they get tired, they get petty, and they are sometimes just corrupt.
The debate sources explicitly point to modern American politics, using past presidents like Donald Trump and Barack Obama as examples.
Just to highlight that humans, regardless of their political affiliation or ideology, operate within systems of immense friction.
Right, they have personal blind spots, they have to worry about re-election, and they make decisions based on human ego.
So the thought experiment asks a radical question. Wouldn't it be better to have an ultra-smart, perfectly rational AI making the ultimate policy decisions for a country?
Imagine an AI Moses coming down from the digital mountain with perfect, mathematically optimized laws.
And to protect it from the garbage data of the internet and the manipulation we just talked about, we don't give it a Wi-Fi connection.
We put it in a sealed room. We feed it only a nation's constitution, pristine economic data, agricultural yields, and isolated, curated facts.
It's the ultimate technocratic dream. And there are two radically different perspectives on this in our sources, mapping perfectly to the two camps of AGI we've been discussing.
Let's look at Pyre's view first. Pyre approaches this with his functional engineering mindset. He argues that an AI Moses could operate as a brilliant, rational agent.
He compares it to a supercharged version of Dr. House from that medical TV show.
Oh, I love that comparison. The whole premise of Dr. House is that he can synthesize incredibly obscure symptoms because he has vast medical knowledge. And, crucially, he doesn't care about bureaucratic protocol or human pleasantries.
He just solves the puzzle.
Right. Pyre imagines an AI Moses operating the same way, using the function calling we talked about earlier.
Imagine an AI Moses that can instantly check poverty statistics in real time across every county, run complex resource allocation algorithms, analyze global logistical supply chains, and output a perfectly balanced tax policy.
And doing it without any human corruption, lobbying, or ego getting in the way, it functions perfectly.
It sounds incredible, but Carrier violently disagrees. He looks at this AI Moses and sees a dystopia waiting to happen.
Carrier argues that an AI Moses built on current technology, even if it's completely isolated from the internet, would inevitably be captured by bad actors.
Because you have to ask the rung 2 intervention question, who curates the isolated database?
Exactly. If you limit its data to keep it pristine, the human programmers who feed it become the ultimate dictators.
Who decides which economic stats go in and which are left out? Who decides how to define poverty in the database?
Carrier's position is that we absolutely cannot trust an AI Moses until it has true self-aware agency, until it graduates to rung 3.
It needs to possess the cognitive ability to recognize when it is being lied to by its own programmers.
It needs to understand the causal implications of its policies on actual human suffering, and it needs to have the autonomy to push back against a bad prompt.
Because a wrong 1 AI Moses will just perfectly execute whatever biased data the programmers quietly feed it.
Which leads to a massive real-world question.
I want to pose this directly to you, the listener. If you're sitting at home right now, think about this. If a human leader starts a disastrous, unjust war in your name, you hold them accountable.
You vote them out, you protest in the streets, maybe they face a legal tribunal.
But if an AI Moses advises that same war based on
Under our current definitions, the doctor gets sued. And they lose their license.
Because legally and conceptually, we define the AI as a functional tool.
It is in the same legal category as a stethoscope or an MRI machine. The human is the conscious agent, the tool is just the tool.
The human doctor takes the fall entirely for failing to verify the tool's output using their own rung 3 reasoning.
But here's the paradox that breaks the system. What if the cognitive camp gets their wish? What if we eventually build an AGI that truly meets Carrier and Pearl's definition?
An AI that has true causal agency, self-awareness, an internal model of reality, and free will.
If that AGI makes a mistake, our entire legal and moral framework collapses.
It shatters completely. Because you can't sue a stethoscope. But can you sue an artificial person? Can you put an algorithm in jail?
If the AI is deemed to have true agency, the doctor might argue, hey, I shouldn't be sued. The AGI made a conscious, independent error.
If it has agency, it has liability. If it's just a functional orchestrator, the human user has liability.
If we don't define what AGI actually is right now, we won't know who is responsible when these systems are integrated into the power grid, the banking system, or the military.
So we find ourselves staring across this massive divide. The functional camp says, stop worrying about philosophy. Look at what it can do. Look at the specialized tools it can coordinate. It's an AGI.
The causal camp says, it doesn't matter what it can do. If it doesn't understand why it's doing it, it's just a dangerous mirror.
The question is, can we bridge this divide? Is there a synthesis? Because living in a state of constant debate isn't going to stop the technology from advancing.
And this is where Pyre introduces a hypothesis that honestly blew my mind a little bit.
It's a way to satisfy both the functional requirement for capability and the cognitive requirement for causal reasoning.
It's a brilliant compromise. Let's go back to Judea Pearl's assertion that deep learning cannot learn causality from raw data.
Pyre actually agrees with this limitation. He acknowledges that an LLM alone cannot organically invent the laws of physics just by reading text.
But Pyers asks, what if the AGI doesn't need to learn causality from scratch?
Right. Because humanity has already done that work. Humans have spent the last several centuries meticulously building mechanistic causal models of the universe.
We didn't just write text, we wrote math. We already have the equations for physics. We have complex control theory in engineering.
And we have highly specific causal models in science. For example, epidemiological compartmental models, like the SAR model.
Let's define that really quickly so we aren't throwing jargon around. What is an SR model?
SIR stands for susceptible, infected, recovered. It's a mathematical model used by epidemiologists to predict how a virus will spread through a population.
It's not just guessing based on past text. It is an explicit mathematical representation of cause and effect.
It calculates exactly how an infected person interacting with a susceptible person causes transmission.
So the SAR model inherently lives on rung 2 and rung 3 of Pearl's ladder. It understands intervention and counterfactuals by its very design.
Exactly. And Pyers' synthesis is this. What if AGI is ultimately just a master LLM orchestrator?
It doesn't internalize causal reasoning within its own neural network. It doesn't have a soul or a mind that understands physics or viruses.
But when you ask it a complex causal question about a pandemic, it knows its own limits. It pauses, reaches out via an API, and queries the SI model.
It queries the external physics simulator. It queries the economic forecaster.
Yes. It acts as the cognitive coordinator of human knowledge, rather than trying to be a universal monolithic solver that holds all understanding inside its own code.
From an engineering perspective, this makes perfect sense. Complex, world-changing systems almost always emerge through the orchestration of highly specialized components.
Think about the Apollo missions that put humans on the moon. You didn't have one single magical machine that did everything.
The Saturn V rocket didn't calculate orbital mechanics, and the targeting computer didn't burn rocket fuel.
You had thousands of specialized, distinct systems orchestrated perfectly by mission control to achieve an impossible goal.
That is a phenomenal way to look at it. Perhaps AGI won't arrive as a single, sudden, conscious God mind waking up in a server room somewhere demanding human rights.
Maybe it emerges gradually, almost invisibly, as a highly capable, functional agent that simply learns to flawlessly orchestrate the massive body of scientific, mathematical, and causal knowledge that humanity has already built over the last 1,000 years.
It borrows our rung 3 reasoning by using the tools we built with it. It doesn't need to be conscious because we are conscious for it.
Which beautifully and necessarily brings us back to where we started this entire conversation. Definitions matter.
The words we use shape the reality we allow to be built.
If you are heading into a public debate, a boardroom, or eventually a voting booth to make decisions about how AI will be governed, who it can replace, or whether it will save us or destroy us, you have to establish the baseline.
You cannot afford to be the person arguing about the chess player while the person across from you is arguing about the weightlifter.
You have to ask the person across the table, what are we actually talking about?
Are we talking about a highly efficient, robotic Swiss Army knife that can coordinate specialized APIs to boost economic output?
Or are we talking about a self-aware entity with a causal understanding of the universe, capable of internalizing its own existence and suffering?
Because if you're arguing about the former and they are arguing about the latter, you're just making noise.
And bad actors thrive in that noise. Knowledge is only powerful when it is clearly defined and applied.
Understanding the mechanical difference between a pattern matcher predicting the next word and a causal reasoner understanding why the word matters is arguably the most important cognitive defense mechanism you can have in the modern information landscape.
It allows you to look at a headline that says AI proves the economy is failing and ask, did it prove it? Or did it just aggregate the sentiment of angry tweets?
Exactly.
But I want to leave you, the listener, with one final lingering thought to chew on, something that genuinely unsettled me while preparing for this deep dive.
Let's hear it.
We spend all this time demanding that AGI must reach rung 3 of Judea Pearl's causality ladder. We insist it must understand why it makes a decision. It must understand counterfactual realities. It must possess deep, unshakable causal reasoning before we will ever consider it truly intelligent.
The gold standard of human cognition.
Right. But look at ourselves. Just look at the state of human public debates.
It's a humbling mirror to hold up.
It really is. Look at voting patterns. Look at the knee-jerk, emotionally driven reactions on social media that dominate our culture. Look at how easily we, as biological beings, are manipulated calculated by volume, echo chambers, and statistical repetition.
Oh, wow. Yeah.
It really makes you wonder, how often do we actually use rung 3? When we argue online, are we exploring causal counterfactuals, or are we just pattern matching the talking points of our chosen political tribe?
That is a very tough question.
Are we holding artificial intelligence to a standard of perfect causal reasoning that human beings barely even meet themselves?